Now, whenever we make decisions based upon data, which is coming from a sample from our population, we never truly know if we've made the right decision, because there's always a chance that we have the data that just does not happen to support the null hypothesis, even when it's true. So what we need to talk about is understanding of what these errors are, how severe they may be, or possibly not severe, and understand how we can use that to make some decisions on what we do when we do our hypothesis test. So to first understand errors, we're going to talk about a situation that most of us are at least familiar with, maybe not firsthand. But let's talk about the idea of someone being tried for a crime. As far as the justice system is concerned, we are supposed to be innocent until proven guilty. So for that reason, the null hypothesis is that the defendant is innocent. Because again, that's what we assume to be true until proven otherwise. The alternative, or in a sense the reason we have the trial, is to show that the person is guilty. So that's going to be our alternative hypothesis. Now when we think through this, we could also make some bad decisions. So what are some possible errors that could occur? And we're going to talk about what the consequences of those bad decisions or errors could actually mean. So the first one means we could find the defendant guilty when in fact they were truly innocent. So again, first of all, hopefully we would all agree that that's an error, that's a wrong decision because they were truly innocent, but we found that person guilty. So what bad things could possibly happen to this person if they were found guilty? Well, of course, depending upon what type of crime we're talking about, the person could go to jail. There could be maybe a fine or some money involved that they would have to pay. There could be maybe even just community service that they have to do. But of course, the reason why these things are actually bad consequences is that all of these things would be undeserved because in fact they were innocent, right? They shouldn't have to do these things because they were not actually guilty. If someone actually was guilty and we found them guilty and they have to do these things, that's perfectly fine with me, right? Because that was their crime that they did that's resulting in those consequences. Now if we talk about the other type of error, so we could find the defendant not guilty when in fact they truly were guilty. One side note before we actually talk about the consequences that could be involved here is actually how I phrase this. So notice that our two verdicts are guilty or not guilty. Notice I never come back and say that the defendant is innocent. We're just coming back and saying that they're not guilty. So this is how we actually are also very careful in our hypothesis test phrasing. We never will say that the null hypothesis is true. We just will not be able to say that the alternative hypothesis is true, which is exactly what we're saying here. There's no evidence that they are guilty. Now talking more about those actual consequences. So what consequences could happen to this person if they were found not guilty when in fact they truly were guilty? Well, one, of course, the big concern that we would have is that this person could be then a repeat offender, right? If they got away with it once in a sense, they might try to do it again. And then, of course, depending upon what kind of crime we're talking about, that may be a bigger deal to us than others. Obviously, if it's murder, we would all agree that we don't want someone getting away with that. Possibly if it's just petty theft, maybe not as big of a deal. But of course, there's always the chance that there's a repeat offender. There's also a chance that possibly someone else takes the fall. Right, if they get away with it, they might try to find someone else to find guilty instead. It kind of relates us back up to our other error there. So something to think about, which of those two do you think is more serious? And why? if I recall what the justice system believes correctly, they believe it's better to let 100 guilty men go free than to punish an innocent person. If that's the perspective you have, then you would agree that the first one is actually the worst one. But there might be times where maybe the second one is worse for you. So my actual answer here is going to be that it depends. And for me, it's going to depend upon actually two different things. The first thing that I would actually want to know is what kind of crime we're talking about. Right, again, as I mentioned before, murder versus petty theft, I might be more concerned about one error in one situation and the other in the other situation. So again, depending upon the crime, that might make a difference to me. The other thing that may make a difference is the perspective that you're coming at to the situation. So for example, if you were the defendant, I'm going to guess that the first one is much worse to you than the second one. However, if someone hurt someone in your family, now perhaps the second one might feel worse to you than the first one. So sometimes we've got to look at the perspective we're coming from. As we begin to tie that back more to actually statistics, we might be looking at some things, for example, from a business perspective versus from the customer perspective. And so depending upon which angle you're coming at it from, one may be worse to you than the other. So now let's actually bring this back to statistics world. So these errors do not have fancy names. They're just called type 1 and type 2 error. A type 1 error happens when you reject the null hypothesis, when the null hypothesis is actually true. This one relates back to our first one here. So if we reject the null hypothesis, we're believing that alternative, so we're going to find the person guilty. But the null hypothesis is actually true because they were actually innocent. So that relates back to our first one we have listed here. Versus the type 2 error happens when we do not reject the null hypothesis. Sometimes also referred to as fail to reject the null hypothesis. When the null hypothesis is actually incorrect or false. So this is like our second one. We did not reject the null because we found them not guilty. But the null hypothesis is actually incorrect because they were actually guilty. So what we would like to talk about then is the probability of these errors. Hopefully you can agree that we would like the probability of these errors to be relatively small. So the probability of a type 1 error is that alpha, that significance level that we've already talked about. So this is where it's going to come for us to be able to talk about why we would set a certain significance level in a given situation. So why that number might change depending upon the example we're looking at. Now the probability of a type 2 error, we have not seen this symbol before. It's the Greek letter beta. And beta, first of all, is not equal to 1 minus alpha because there's not going to be a 100% chance that we make an error. It's a separate value in itself. Finally, before we try to summarize these things together, there's one other term that I'd like to talk about, and that's what's called power. Now, the first thing I want you to realize about power is that this is a good thing. So we're not making an error here at all. It's when you reject the null when you should. So this would be like finding our guilty person guilty. So we're making the right decision. And the probability of power is 1 minus beta. And I think it helps to look at this in a chart form. So we're going to look at our decision that we make, which is like our verdict in a trial. So we can either reject the null hypothesis or not. And then there's going to be the truth which first keep in mind we're not actually going to know the truth, but there is the truth. So the truth is either the null hypothesis really is true or it really is false. And so now this has sort of got me these 4 boxes that I can possibly be in. And so we're going to take these terms that we just learned and figure out where they belong in these boxes. So if I reject the null hypothesis when the null hypothesis really is true, that's exactly how we defined a type 1 error up here. So this is going to be our type 1 error. If I reject the null hypothesis when the null hypothesis is actually false, first of all, that's a good decision, so I'm not making an error here. More specifically, though, this is exactly actually what power is. It's rejecting that null when we actually should. Moving down here, if we do not reject the null when the null is actually true, so this would be a not guilty verdict for an innocent person. Again, we're not making an error here. And this one actually does not have its own specific name. So sort of by default, we can probably figure out this last one is, but let's still talk through it. So if I do not reject the null when the null is actually false, that's exactly how we define this type 2 error above. So the last thing I'm going to add is actually the probabilities here in the corner. So we already know the probability of a type 1 error is alpha. The probability of a type 2 error is beta. Power, as defined above, is 1 minus beta. This one down here is actually 1 minus alpha. So what you might notice is if you add down, alpha plus 1 minus alpha is going to give me 1. And 1 minus beta plus beta will also give me 1. So if I add down each column, I get 1. So it makes you sort of question then that my total probability here is actually adding up to a number that doesn't make sense. It's adding up to 2. So the reason why each column adds up to 1 is because you're only going to be in one column. When you're doing an example or there's a trial, either the null hypothesis really is true or the null hypothesis really is false. The reason why we're collecting data or why we have the trial is because we don't know which column we're in. So that's why your columns will add up to 1. So you're only going to be in one column, you just don't know which column you're in. Now to talk about some relationships between our alpha and beta. So notice we can actually control alpha, that significance level we can set for the problem. So I can control that number. But then how do I really talk about beta? So generally if I decrease my alpha, so if I make the probability of a type 1 error smaller, I will increase the probability of my type 2 error. What that also means is the opposite is true. So if I were to actually increase alpha, that's going to decrease my beta. But finally, an overall increase in sample size will reduce the chance of either error, which hopefully makes sense because then the more data you collect, hopefully the better chance that you're going to make the correct decision. So we want to talk about this with how it relates to why we set a certain significance level. So there's 3 things that could happen. So we could decide that depending upon our situation and perspective, a type 1 error is worse than a type 2 error. We could instead find that a type 2 error is worse than a type 1 error. Or we really could possibly decide that there really isn't a difference and they're about the same. They're both equally bad or not concerning to us. So depending upon that, we can set our alpha level. So if our type 1 is a worse, we would like alpha to be small. Alpha is what we can control. So generally the smallest alpha we see used is about 1% or 0.01. If a type 2 error is worse, I would like beta to be small. I don't have control over beta directly, But if I want to decrease beta, I can increase my alpha. So we're going to use a larger alpha level, and generally the largest we see used is about 10%, so about 0.10. And then finally, if the errors seem to be about the same, that's when we use our standard of that 5% or 0.05. So that is how errors are going to be related to why we set our significance level the way we do. In the next video, we're going to be doing an example, and we will actually address type 1 and type 2 error in context with that problem as well. This won't be the only time you see type 1 and type 2 error.